Welcome to Maths with EJD. In this video, I'll be talking about normal form games, still under game theory. And to start that out, let's look at uh, game representation, game representation in normal form. So, a normal form game is a mathematical representation of a strategic interaction between players, of course, which is in essence what game is. What a game is. A normal form game is a mathematical representation of a strategic interaction between players where, first of all, talking about players, we already said they are individuals or entities making decisions. Okay. Then next, we have strategies, just like we saw in the previous video. We have strategies, which are the possible actions available to each player. Then we have payoffs. We have payoffs, and these are outcomes. Payoffs are outcomes of the game expressed as numerical rewards based on the strategies chosen by all players. Okay. Um, the game is typically represented as a matrix for two players or as a multi-dimensional multi-dimensional table for more players. Okay. Each cell, each cell in the matrix corresponds to a specific combination of strategies and contains the payoffs for each player. Okay. All right. So let's talk about the components of normal form games. Components of normal form games. Of normal from games. Hmm. So number one, we have the set of players. We have set of players n. So we can have the number of players one, two, up to whatever number, up to n. That's set of players. Then the second thing, we have strategy sets. Strategy sets. Strategy sets. SI for each player. For each player I, where SI belongs to where strategy I, right, belongs to the bigger set of strategies. Okay. Strategy sets for each player. Then number three, we have payoff functions. Payoff functions. So say you have UI of S1, UI of S1, S2, all of that down to Sn. So that's the payoff function, which map the strategy profiles, which map the strategy profiles to numerical payoffs. Okay. Now, let's look at an example. Let's look at an example of simple games. Example of simple games. Here, we focus on the prisoner's dilemma. Prisoner's dilemma. So the prisoner's dilemma is a classic example of a normal form game. Okay, here we have two players. The two players are prisoner A and prisoner B. So the two players. So they are arrested for a crime. Okay. So I see what are the options available to them. Um, they can either they can either cooperate, they can choose to cooperate. So choosing to cooperate, that is C, and that means they both remain silent. They both remain silent. Then the other option they have is that they can defect. They can defect, that is D. In that case, they betray each other. Betray the other, rather, betray the other. So those are the two options available to these two prisoners. Okay. Now, the payoffs, the payoffs are determined based on choices made. Okay. So, and imagine if, for instance, if both cooperate, if both cooperate, they get a reduced sentence. They get a reduced sentence. e.g., 1 year each, 1 year each. That's a reduced sentence. If then two, if one defects, if one defects while the other cooperates, while the other cooperates, okay, the defector goes free while the defector goes free while the cooperator the cooperator gets a harsher sentence. E.g., 0 years, 0 years for the defector and 3 years for the cooperator. Okay. And then the third thing is that if both defect, if both defect, that is, they betray each other. So that means they get a moderate sentence. They get a moderate sentence, e.g., 2 years each. But you see, it's a dilemma because you never can tell what the other person, I mean, one prisoner cannot tell what the other prisoner is going to do. That's where the problem lies. So let's look at how do we represent this? How do we represent this scenario? So let's look at the representation. Representation. So here we have uh this is prisoner A, prisoner A. I'm trying to look at it very nicely to do this. Okay, this prisoner A up here, prisoner A there, and we have prisoner B here, prisoner B. Okay, so prisoner A has two options. So, and the options are, okay, I guess I can do it this way. So prisoner A can cooperate. Prisoner A can defect. That is C here, D here. On the other hand, prisoner B, okay, I guess I want to move it up. So prisoner B can also choose to prisoner B can choose to cooperate or defect too. So cooperate, that is C. Prisoner B can also defect, that is D. Okay, I think this represents it well. Yeah. So this is the kind of situation we have. Now, so the payoffs are what we are going to have in those four boxes now. So if prisoner A cooperates and prisoner B also cooperates, so they get a sentence of 1 year each. You remember? So they get -1, -1. 1 year is like -1 year of their lives because they'll be spending the 1 year in prison. Now, if prisoner A cooperates, but prisoner B defects, okay, it means that the prisoner A is going to get, so if prisoner A cooperates and prisoner B betrays prisoner A, Um, it means that prisoner A is going to get maximum sentence of 3 years, while prisoner B, who defected, who betrayed prisoner A, is not going to get any sentence. Okay. Now, if prisoner A defects and prisoner C cooperate, prisoner A defects and prisoner B cooperates, what's going to happen there? It means that the one who defects again is going to get no sentence. So it's going to get 0 years, while prisoner B, who did not cooperate, who defects, who cooperated rather, who kept silent, is going to get 3 years sentence. But if they both defect, they both betray each other, so they're each going to get moderate sentence of -2. So that's how this is going to be represented. Okay. So those are the payoffs right there, depending on whatever actions they are taking. But the trouble with this, the reason why it is called prisoner's dilemma is because prisoner A doesn't know what prisoner B will end up doing, and prisoner B doesn't know what prisoner A would end up doing. That's why it's a dilemma. So here now we say that payoffs are negative. Payoffs are negative to reflect years in prison. So each cell represents the payoffs. So all the -1, -1, -3, 0, 0, -3, -2, -2, they are the payoffs. So each cell represents the payoffs. That is for both prisoner A. The first one is for prisoner A, and the second one is for prisoner B, as you can see up there. So that is how to represent the prisoner's dilemma in, that's the kind of matrix representation of that. Okay, so let's talk about pure strategies, pure strategies versus strategies, pure strategies versus mixed strategies. Okay, so first off, pure strategies. A pure strategy involves choosing a single action, choosing a single action with certainty. Okay, in the prisoner's dilemma, in the prisoner's dilemma, choosing cooperate, or defect without deviation is a pure strategy. Okay. Then we can talk about mixed strategies also. Mixed strategies. So here, a mixed strategy involves choosing among among available pure strategies according according to a probability distribution. For instance, a player might choose The player might choose cooperate with a 70% probability and defect with a 30% probability. Okay. So we can narrow that down to to two key differences. Key differences. So we have pure strategy. So pure strategy is deterministic, no chance, like it's fixed. It's deterministic, always, always picks the same action, always picks the same action. So you can be sure what is going to happen for someone who chooses pure strategy. Then when you have mixed strategy, you have a bit of chance thrown into it. So mixed strategy. So this is probabilistic, and it allows for randomness in decisions. Randomness in decisions. Okay. Um, mixed strategies. Mixed strategies are particularly important in games where no pure strategy, equilibrium exists, as shown in games like matching pennies, matching pennies, or certain zero-sum games. So as we go on, we'll be exploring some of these things better. So that's how this has been, talking about normal form games. So basically, talking about how to represent games in a tabular form, just like we see with the prisoner's dilemma, where prisoners A and B have two options of either to cooperate or defect, and a mix of these decisions will lead to the kind of payoffs, the prison sentence they end up getting. So it's such an interesting thing. So come along um, as we continue after now. So subscribe to the channel and hit the notification bell so you can always get alerted each time a new video is released. Comment, let me know if you want me to clarify something, teach a topic, solve a problem, and like and share also so that more people can have access to this great learning. Till I come your way again, keep playing the game of life with wisdom. Bye.